Welcome. Hello, my name is Keith Parsons, and today I have Ben Toner with me from a company called Numerous Networks. And Numerous Networks has just launched a new product called nOversight. It's a mobile log analysis software. That's a fancy way of saying it allows you to look at the log files coming off of iOS devices and on a Mac OS device do interpretation and etc. So rather than have me talk about it, we've got Ben. Ben, how are you today?
Hi, Keith. Yeah, I'm great. How are you?
Great. Oh, luckily, I was one of your beta testers when you first rolled this out a little while ago
Right.
and had a chance to see it and play with it a little bit ahead of the rest of the curve. So thank you for that. Uh, your website is
Numerousnetworks.co.uk.
numerousnetworks.co.uk, and we'll put that in the show notes. So before we get started in actually looking at what the software is, what was the problem you were trying to define when you started thinking about this?
So, my background is that I have been helping carriers with something called convergence, the bringing of Wi-Fi and mobile together for better mobile experiences. And through 10 years of trying to do this, the one thing that always got in the way was you could never quite tell what an iOS device was doing. It's actually quite hard to tell what devices are doing, but specifically with iOS, you were trying to look at network transitions, when it was associating to Wi-Fi, why it was associating to Wi-Fi, why it would leave. And what we were trying to build was effectively a connection manager that could select Wi-Fi at the right time and disconnect at the right time and help in the early days of Wi-Fi make those better decisions. But the problem with iOS was it just had a mind of its own. Well, it doesn't really have a mind of its own. What it's got is a bunch of complex.
It has a proprietary algorithm.
Right. And there was things in the wind that you could hear in terms of, oh well, it'll prefer better security, and it has some level of memory, and it learns about what's your home network and which ones you've connected to recently and so on. And all the way through that time, when we were heads down, really busy getting the main product out at the time, and this was in a previous company, we never quite got round to solving this problem. In November 2019, I went solo and started my own consultancy around convergence and the introduction of Wi-Fi into mobile for better mobile experiences. And I decided I was going to do something about it.
Stop you there for a second. Just for our US-based listeners who are tuning in, when you say mobile, you mean cellular.
Cellular. To put that into context, the kind of organizations I was working with was Comcast before they actually became an MVNO, Deutsche Telekom, and Vodafone in Germany, and BT, and all of these big companies who wanted to introduce better Wi-Fi. And so anyway, since going solo, I just decided that, you know what, it's about time we got a handle on this and just bring some of the insights or oversight, for that matter, on what iOS is doing. So why don't we just help people understand this? And the idea was, it's easy to get a professional in and install a network, but they're not sitting with you all the times. And if you're in charge of a big corporate LAN or a big theme park or a train station or whatever that may be, it's not a bad idea to be able to walk around and just see how iOS devices are really working in your network under all the different conditions.
Okay, so Ben, tell me why you didn't just write this as an iOS app. If what you're really after is iOS decision data, and that's decision data both roaming from Wi-Fi to Wi-Fi, but also at some points in time, it might go Wi-Fi to cellular.
Right. So the big thing, of course, has always been that iOS has been relatively locked down. The information about what iOS is doing, what it's connected to, even simple things like signal strength, have just not really been available. And APIs did come out. So there's something called the Hotspot Helper that did come out, and it started to bring a level of knowledge, but it was understandably by Apple protected to a point where it really only lets you do what they think an app should be able to do. And that is not very much with regards to the detail that we're looking for in the professional industry. Incidentally,
do they keep logs that act? I mean, if they won't show it to you in an API, but are they carrying the information you want someplace?
That's right, they are. They're carrying it in the logs, and many of your listeners who are in the professional industry will know you can get a log called the Mega Wi-Fi profile that will bring out a log that will give you all of these and save it to a file. But if you try and read through it, the problem about the way iOS does things is there's a lot of processors running on the device. There's a Wi-Fi daemon, there's a kernel, there are all sorts of authenticators and so on, and they're running to some degree asynchronously. And these logs therefore end up quite mixed up. They're hard to decipher. It's hard to actually know what's going on. So it turns
How
out
far off, if they're not synchronized, are they half a second off or 5 seconds off?
that's not the problem. It's more like you've got the kernel telling you that it wants to move to a new BSSID, for instance. But the actual Wi-Fi system hasn't made that change yet. And it then goes and does a whole bunch of quality metrics. So it's very easy to get misled by saying, oh, right, the kernel's changing, but actually the system may or may not change at that point in time. And you get certain bits of information like what's the channel and what's the bandwidth from certain subsystems like the kernel before maybe even the whole Wi-Fi has changed. So you would need to know when you look at those logs to look back in time before the change to find certain bits of information. And what we've done here
I'm gathering you didn't find that right away when you first looked.
So we knew that, we suspected that. So it's always been difficult. I think I've gone down, in my past, I've gone down the route a lot of people have gone down, try to write a few scripts and so on. It doesn't really cut it. You need a full-blown state machine to track. You need a knowledge of Wi-Fi and the ability to build a state machine that actually tracks a Wi-Fi system and then says, okay, if I was building a Wi-Fi system, what would I want to know? And you start collecting that information and piecing it together. And then when you get certain signals, like you've moved to the associated state, you can bring all that historical information and go, okay, this now applies, and so on.
It sounds like you're looking through a glass darkly. Like you don't get to actually see it directly.
That's right. And by no means am I trying to give a deterministic view on saying this is exactly what's happening in the Wi-Fi world. All I'm trying to really do is interpret logs in a logical fashion to help the industry understand what they mean, present them in a way which is easy to view, and especially when you're sort of an IT person looking at managing a network, you don't want to sort of stop and then look at a whole bunch of text on the screen. You need to be able to see quickly what's going on, actually do a test in a problematic area and see something actually happening. So yes, you
Well,
are.
I have a question for you before we get into the demo of the actual product. What's the differences between a Wi-Fi ROM to another AP, so just switching BSSIDs, that's a normal Wi-Fi ROM, versus a ROM off Wi-Fi onto cellular? They have two different techniques to do that. Is Apple sharing anything about that, like they did with what they're looking for Wi-Fi to Wi-Fi?
So nothing is particularly shared in explicit terms. What we're doing here is kind of bringing out that information to allow the professionals to work that out and to validate anything that they may already know. So, for instance, what you might know is that you need a certain RSSI level to have been surpassed in order for the device to start thinking about roaming. And what I'm doing is bringing that information to the fore so you can say, well, okay, I can see the RSSI has dropped. Let me see, are there roaming events going on? And you can see from the tool that the subsystems are coming out and saying, I'm interested in roaming. Why? I've lost some beacons, or the RSSI is too low, or so on. But then you can also tell the difference between a plain old disassociate, I've got to find a new Wi-Fi. And you can actually now understand from this tool whether it was a roam, AP information being given to the client to suggest a roam, or there was a dissociation event followed by a new scan.
Now, a lot of our listeners, anyone who's CWNA or specifically CWAP qualified, they understand that process and the different choices that go into those algorithms. Is your tool targeted at that kind of wireless LAN professional, or are you going for a broader, just IT guys who don't necessarily understand how 802.11 works?
Well, both. So to start with the professionals, what I want to be able to do is provide validation. So a professional who designs a network and says, well, this is what I've designed my network to, these are the parameters. It should work in a particular way, and they've got a lot of knowledge about how iOS's devices work. But to then be able to walk around and validate that the ROMs are triggering where they think they should be triggering, and check all of that. But specifically also understand whether there's anything like if an iOS device starts tracking a network as a home network, so for whatever reason it sees the device there a lot and it thinks it's a home network, does it act differently or to one that doesn't? But then going up the scale, the whole point of presenting it in an easy way is to be able to let the sort of the IT person and the person with slightly less depth, or a lot less depth, in fact, also understand and say, well, okay, well, I'm managing a corporate network here. There's an issue. I can walk around and just see what's happening. Is my device actually roaming like I think it should, like when on the day it was set up, or has something changed? Is something working differently now?
So your software runs as an application on Mac OS device. What do you have to do on your Mac to get it to be able to work on this platform? I mean, you're talking to an iOS device log, but you're on a Mac OS. How do you make those two things talk together?
Okay, so there are some tools that are available on the Mac. So there's automation tools. One of them is called CFG util, so it's a config util. It's a standard Mac tool, and we're just harnessing that. Anybody can go and install that tool, and the application, in fact, gets you to install it if you haven't, by identifying that it's not there. And anybody can go into a terminal, and anybody can actually run the right commands and get these logs and bring them into a file and look at them. And all we're doing is taking that, using that, because at the end of this, we don't want to do anything which would be classified as reverse engineering. We're just doing normal engineering analysis of something that is provided freely by Apple, and then just arranging it in a way which is presentable and easy to understand.
Great. So nothing magic there other than just using the tools that Apple's already provided. If so, I would need to load this Apple configurator tool on my machine. When you're doing this walk around analysis collecting log files, do you have to do it with the iOS device and the Mac device together? Or can I just walk around with the iOS device and come back and upload?
Okay, so the product's just launched, and the very first version requires you to walk around with the Mac and the iOS device together. And yes, that is very much understood to be what we might call clunky or awkward, but it at least allows you to do the job and get the insight you want. The roadmap allows us to break away from that slightly. So there are a number of things we can do. There are some open source replacements for this configurator tool, and we have a plan to put that on smaller devices like a Raspberry Pi, so that you can record a log on a much smaller, easy to carry, easy to walk around with machine, and then bring the log back. This is the basic version that we'll look at today, and that's what's launched. We're developing a pro version which will allow you to record and play back logs. And once you've recorded them on a separate device, you'll be able to bring the log in, and if you own the pro version, load it up and then play it and sort of scroll through time and see what happened on your walk. So that's the basic idea of getting untethered.
So this is actually a good place for me to put a plug in for our WLAN Pros survey trays. If you have one, that's what I used when I played with this software. It allowed me to have my hands free, and my Mac was on the tray, the iPad was on the tray, the iPhone was on the tray, and I could swap them all out.
Yep. The other thing is there's been a request come in. So what I found, by the way, what I found absolutely fantastic was, Keith, with your community and through Twitter and LinkedIn, you helped spread it out through the bigger community of wireless LAN pros. So we got a nice big group of beta testers who checked it and found some early bugs and so on, but also brought a whole bunch of suggestions. And one of them has been, could we get the mega Wi-Fi logs and parse those? And so we've put that on our roadmap, and that'll be the next step. So for the pros who know how to do that, and we'll provide guidance. So one of the aspects of this tool is to help people just make it easier to do these things. Install the profile, walk around, bring it, download it, and analyze it offline. So that'll be another feature that we're going to introduce as well.
So you take the phone, you plug it in with a USB into your Mac, it finds itself, and you start collecting data. So you have two different monitors. One is for Wi-Fi and one is for cellular. What are the differences? I mean, I understand why you need both because there's two different sets of data. What are the differences between a cellular connection and a Wi-Fi connection?
Okay, so we started out with two monitors, one for Wi-Fi and one for cellular, as you said. And the reason being is we wanted to allow people to understand when the device is moving between the two networks and understand things like, how strong was the signal, the cellular signal or the Wi-Fi signal at the time of the transition, and was that good and did that make sense? And another reason for that is because one of the roadmap items and the way we're going to go, I said at the beginning of this conversation that one of my topics is convergence, the bringing of mobile and Wi-Fi together. And one of the features that we're going to pull through, hopefully quite quickly now, is the ability to see multipath TCP. So when you run an application that uses both Wi-Fi and cellular at the same time with different streams, then you will be able to, through this tool, see the data, the aspect of data moving through each of the interfaces, and we'll start to show that. So we wanted to show both interfaces because they are becoming important in a converged world. And as you probably all know, Apple use Multipath TCP for Maps, Siri, music, and others like the Alexa app use it as well if you make a call and so on. So it's being used, it's becoming something in 3GPP, it's becoming a big issue to introduce these convergence technologies. So that's why we have both. But one of the things also is the cellular tab, one of the changes we made because of the community suggesting it, was we allow it so it flips around and it becomes a Wi-Fi roaming manager. So if you're not interested in cellular, you can flip the card around and see exactly a lot more detail about why the last roaming session occurred.
Good. Is there, just a question, since you seem to be very knowledgeable in this area, if you're doing a Wi-Fi call, and depending on what your vendor, your cell company of choice is, they might call it different things. But when you're going to be using Wi-Fi as your voice backhaul and cellular's there, is there a decision, an algorithm in there to trigger when it's one or the other? And do end users have control over that?
So yes, so whether you do Wi-Fi, if Wi-Fi calling is supported, and so we're talking about predominantly 4G networks now where it's supported as what's typically called voice over Wi-Fi for the 3GPP people out there. It's an EPDG connection into the cellular network, and the thresholds at which you do a voice over Wi-Fi call are managed by the carrier file. So effectively the bundle that comes over the air when you put your SIM card in that says, look, this is when I want to use voice over Wi-Fi and this is when I don't. And when voice over Wi-Fi first came out, it was a little more biased towards using Wi-Fi in terms of, well, if I'm on good Wi-Fi in the home, then great. But it quickly got found out that it was hard to maintain that at scale, and the cost of maintaining lots of inbound Wi-Fi calls was slightly higher. So a lot of the profiles changed over time, and you'll generally find your phone, depends on your carrier, but a lot of carriers tend to will prefer VoLTE a little bit more because we're dimensioned for that, and the system is set up to prefer that. and will go for voice over Wi-Fi when the cellular quality would otherwise be bad for a voice.
So end users don't have much control, but there is control. It's not in our hands. It's
Right.
in the carrier's hands. And hopefully the carriers are making proper decisions.
That's
So
right.
how would you use this tool? Say you're a Wi-Fi designer, you just got done installing a network in a hospital, and you want to validate that not just is there RSSI everywhere, primary and secondary, where's my good coverage, but how are Apple devices actually going to run? So walk us through the process of how you would validate a new install.
Okay, so you would walk around. So let's assume we're at the stage where we've got the pro version out. So you'll be recording this, and you'll be able to record it at various stages thereafter to do comparisons if you ever make adjustments. But as you go and do your walk around and record, what will be recorded is the RSSI and the signal to noise ratio for each BSSID, and then how the roaming occurred. So when we go to look at the tool, you'll see various things like roaming attempts. And each attempt, when the device is saying, I've got low RSSI, I'm going to go looking, and then abandon. And what has come out of the work that I've done is you can actually see how many, like 5 or 6 or 7 attempts sometimes of an iPhone trying to say, I'm looking for something else. I've got a reason to look for something else. And if you are validating, you would want to see that the device roams appropriately when you expect it to. You don't have any kind of holes as far as an iOS device is concerned. But also, what's the load on the iOS device? When is it trying to roam? Why is it trying to roam? And how many times does it try to do that before it eventually does? You can also see when the AP, if you've got something like band steering turned on, you can see when the AP is actually trying to suggest that the device roams, and then whether the device does accept that or not. So you can validate that side of it too.
And since we're dealing with iOS devices that support KVR, do you get that KVR information in the log files as well?
You don't. You get a reason code, which is an IEEE reason code, and so you just make of that what you will. There's at least as far as we've uncovered so far, there's nothing specifically that says this is a KVR type ROM.
So you'd kind of have to back into it. If the AP said, I suggest you go to these APs, then in your log file, you might see that it actually did attempt to hit those same APs.
Yeah, so in the file, you can see that you can see when the device says, I'm looking for a roaming candidate because the RSSI is low, or that beacons have been lost, or so on. But you can also see when the AP has said, I suggest you make a change, and then you can understand. Then you'll be able to see sequentially whether or not it responded to that and how it responded, and whether it made the change or just ignored it and went on its own way.
Great. One of your other screens shows a session history over time with little bars showing when you roam from one BSSID to the next and back and forth. Do those also show a gap if it took very long, or if it didn't do it, it wanted to but it couldn't? Does that show up in the graph as well?
Yeah, so the whole purpose of showing some time like that is to identify when the iOS has done something which was maybe not too slick. And so that was one of the things I noticed in my past a lot, is when you were switching between, especially between SSIDs, or if you didn't have some kind of seamless roaming setup and it really needed to go right back and reassociate, you sometimes see iOS play about with the default route. So you can see this for yourself without any tools, where you turn on an iOS device and if you switch between two SSIDs, you sometimes see the little check mark come beside your SSID and then go away briefly and then come back again. And on the time chart, what you would see is the session go to the new BSSID and then back up to cellular and then back down again. And that's really helpful for understanding, is there something within your network that you could do about this or not? Now, iOS does this. It's a thing it does. It tries to never let you be on an unroutable connection, and it's part of its captive network management. So it's essentially, if you're stuck on a captive network, it allows all the traffic to continue over the cellular interface until the captive network, which has been privately bound to, has been associated and authenticated.
Well, great. How about if we jump into a demo? You got anything to show us?
Yeah, sure. So here you can see it on the screen. Now it's just sitting on my desk, so it's not particularly eventful, but I'll do some things. So when you plug your iOS device in, you get a little ID, connection information up here, and you can flip it around and see what it is, and you can stop and start. As we just discussed, you can see that there's a time bar at the bottom showing what I've been connected to, and it's monitoring my RSSI, signal to noise ratio, giving me some credentials from what iOS thinks it's connected to. So the things that you would normally know in terms of, well, what is security and what standard it is, but other things like what does iOS think about it? Is this a home network? So that's quite helpful. And then on the right,
Just a side note, do you have the ability from it's feeding back in the log to track what the MCS index is on that device at any over time?
So there's not a specific MCS output being reported as that we've found right now. So you're getting signal to noise, you're getting RSSI, you sometimes get information, but it's inconsistent about what the max MCS of the network might be. But
not a current that's timely over time. Okay.
Unfortunately not, and I appreciate how valuable that would be. But
yeah, that would be that's the one I'd like to track, because it's self-reporting of how happy the device is at that moment. RSSI could be high, but if I have really low MCS, then it's telling me there's something else going on in the RF space, or the reverse. So
yeah, so you can get some of the way towards it, obviously through the SNR to help you understand whether you've got interference, of course. But this quality indicator is iOS's internal link quality manager. And do
they only have those 3 levels?
It gives 3 states out currently, which is off, poor, or good. But it's
wow, such granularity. I'm so impressed.
It's related to data flow. So that's more of an actual data quality. So you often see that when you first connect to a network, the quality is defined as poor, even though you might have a great SNR. And the reason for that is very simply that not enough data has gone through the network for them to have done a valid test yet. And eventually it becomes green like that, saying that it's in a good state. And you see that as you kind of walk around, and if your roaming is not set up too hot, and you get really quite low RSSI and effectively low SNR, you start to see the indicator drop. Especially if you try to do something, I would encourage users of this app to do a walk test with data flow. Run a YouTube channel, look at something on a web page, do whatever you want, but actually push data through. And of course, when the new features come out with Multipath TCP, that's exactly what you'll want to do: push data through to see which route it takes. Anyway, so back to this. One of the other neat features is we can tell whether you're connected with a private Mac or not, which is going to be helpful to people who are concerned about Mac privatization. And then on the right here, you can see the current BSSID it's connected to and why it connected. So this was what iOS reports as a join. This is the RSSI and time it joined at, and this is the current status. But you can see what I've been talking about here, that whilst we've been sitting here talking and it's been sat on my desk, the RSSI has been dropping, probably as I was waving my hands over the top of it in front of me. And we're getting iOS telling us, look, I've got low RSSI, so I'm interested in roaming. Let's take a look and see what we can do. And then it says, okay, well, a status 3, which is a failed due to no matching network found. So it didn't find anything it wanted to go to. And it has repeatedly done this quite a lot. Down below here, you'll see the previous session before I turned it off and on. And now you can see why it left the previous session, because I went to the control center and turned it off and on just to get something populated in the box here. But while it was on that one, it was also doing the same thing. And in there, you would also see if there was a request from the AP to make a ROM or whatnot. And as I said, then if you click that, you can also flip the card and you can see the cellular session. Now, unfortunately, you don't get anything nice like the signal strength in the way you might want it. So RSRP or RSRQ you cannot get.
Bars. Woo.
Yeah, which is not particularly great, and you need the screen on because it's reading it from the screen log effectively. So it's not great. It's not huge. But anyway, just to kind of put this into context, if I was to turn off the Wi-Fi on my device, you'll see now that the session has switched to a cell session, and the Wi-Fi card is no longer populated, and the primary network has moved over. So you can see which route is being used for the traffic. And then if I turn my Wi-Fi back on, you see the primary route change, everything populates, and that comes over. And then the other thing I can do just for completeness is switch SSID. Which I'll do. And now you can see what we were talking about. As we switched to SSID, it came down here, started to associate, wasn't quite sure that it could route. When the default route came back up to cellular, but the Wi-Fi daemon was still associating in the background, checking whether the internet was reachable and all those things. And when it was happy, it came back again. So you can actually see what happens in real time when you make those changes.
And you would hope that if you were doing a hospital and this was a tablet the doctor's using, that it doesn't have that jump back to cellular in between, unless it's got a multipath TCP going.
Right, and eventually what you will see when we do update this is we'll show multiple simultaneous routes, and we'll be identifying which one's carrying data, potentially both. Yes, what you're looking for, of course, is that if you've set up your network well, when you're just roaming without an actual forced change of SSID, that kind of event's not happening. If you're changing SSID, that's probably just going to always happen. It doesn't always happen, but that's something you'll never get away from. It's not down to the design of your network.
A lot of iOS devices in more enterprise space take out the SIM and go with a Wi-Fi only basis to keep costs down, or using iPod touches or something. Have you ran this software against an iOS device without a cellular option?
Yeah, absolutely. We've run it with tablets, so it works on iOS and iPad OS, so it's just fine on both of those. That's why we actually I've just flipped it back to this card here, so we can show just Wi-Fi. So for anyone who's looking at a Wi-Fi only device and trying to understand its behavior, you would put it in the state as seen on the screen there, and then you'd just be able to measure it from what does a Wi-Fi only device do,
and probably have that same gap as it was figuring out its route.
Well, not necessarily, because if you pull a SIM card out and there's effectively no better route for it to go to, it might as well just leave you where it is.
Sounds like something I need to try.
Yeah.
So if anyone else wanted to play with this, what kind of licensing options do you have available today?
Okay, so right now the basic version has been released, and really it's a simple, low-cost, one-time license, and it allows you to buy it for a perpetual point in time. Just you can use it as much as you want. It will be updated, so it's automatically updated, and as we produce new features and so on, with relation to the sort of Wi-Fi, it will continue to be updated. There's a pro version going to come out, which will be a monthly license, and that will be very affordable as well. And the idea behind that is the main feature it's going to include is the ability to record and playback, and introduce the ability to record it outside of your Mac as well, so that you can bring in externally recorded captures and play them afterwards and scroll through. And then the Multipath TCP will appear in the Pro version as well. There'll probably be a hint of it in the basic. So those will be the two options that are for most people. And then we've opened up an enterprise option, which is still being scoped. But essentially, the idea behind that is if you've got a lot of people, let's say you're managing Disneyland, and you've got a lot of people and you need to do a lot of recordings and you need to have a lot of licenses and you want to compare and bring lots of recordings together, the enterprise version will be a custom package for anyone who wants to do that, who wants to walk around their park, 10 people walking around their park, checking it all out, and then merge it all together and be able to view in a bigger dashboard. This is something, a little further down the roadmap, but we're certainly interested in enterprises who'd like to get in there early, steer us with what we're doing, and help us, define the product correctly for them.
I love the differential part. The other one might not be that they all of them go at the same time. I'd like to go baseline, this quarter and come back after we make a change and run the difference and see if there's any differences. Or when iOS 15 comes out to see why it's better or worse than the previous version. So a baseline and then a comparative would be helpful as well.
Yeah. And so what we need is the market to tell us. We've done what we've done here because we thought it was interesting, and quite frankly, it's quite fun to kind of have revealed this, I suppose. And I think
all the data has always been there. It's just reading it and correlating it back together is what you've done a great job of.
Yeah, thank you. And it's been a great journey. So now we need the market to really tell us how much more effort to put into this. Is it something that in the basic form where you just walk around, that's going to be enough? How interesting is it that we can record and play back, and what size of the market is there? So we're willing to put ourselves out there and put this version up, but hopefully the community will come back and tell us what they want and help us size how good this will be and how much effort we should put into it. But I'd love it for it to be a big thing that keeps on growing.
Well, that's what we're here. And I also see versions of finding out what a base iOS device would do with just like YouTube streaming versus a same iOS, but with some other application writing on top. There are companies who sell communication software packs that go on top of iPhones, and I'd like to see if how much they're the same or different than just the stock iOS.
Yeah, I think the opportunities are endless, because what we've done is we've unlocked the ability to accumulate logs and present them in a nice way to understand. And we can do custom developments for people, or we can just kind of carry on our own path, or a bit of both, and bring these things out. But absolutely, that's the thing that is going to be the big game changer, is that getting the right networking and the right data paths, especially in multipath environments, for the applications that are running is where it's at. It's about, this thing here that should be really high latency sensitive is going to go over the cellular network right now, because the Wi-Fi network assessment says this is not ideal, or the latency is not ideal, or there's too many handovers, or whatever. So as you run different applications with different needs for latency, for bandwidth, for resilience, you're going to see different aggregations going on of the network, and different handover points and different changeovers of the different paths on a per application level. So we've just opened up the world to be able to go and try and do this.
Well, there could be other developers who could use this just to document and validate whether or not their coding is doing what they thought it was doing.
Exactly right. So we do encourage anybody who wants, sort of custom insights on whether their application has done the right thing. So you can imagine anybody who's got, a large subscriber base, and they rely on real-time, low-latency communications. How is it working? With our knowledge of building this, we also know how to build a good test environment where you are really driving typical use cases. What happens when you go right to the edge of Wi-Fi? In your community, so many people are trying to build a great network, but I think testing for what happens when it's not great is equally as important.
Or to prove that your network is great and it actually does work.
Yeah.
Then you can walk away. So just to end up here, Where'd the name nOversight come from?
um, because it's an interesting story, and it really wasn't the original name. It's not the working title of it. It was actually called Logeye, but you probably know of another popular company who used that terminology. So we had to change it on the fly, and I kept looking at a couple of companies like VMware and so on who put a little V in front of everything, and I thought, well, I'm Numerous Networks. I'm going to put a little N in front of it, and I'm going to be different. It's not, there's lots of things called Insider and Insight and all that kind of stuff. So this is an oversight.
It's oversight.
Yeah.
Yeah.
So
it works well, and it's memorable as well. Well, we'll put in the show notes. We'll add links to Numerous Networks and some other graphics that are available in your help file on how to use this. It's actually a very simple product to use. Takes I don't know, a minute or two to download the installer, to put it on your Mac. Find the USB cable for your iOS device, connect up, and it shows up right on the screen. So it's something you could use to help you evaluate how iOS devices are making roaming decisions on your current network, or to baseline improve whether or not the updates you did fixed or made it worse. So thanks to Ben Toner for joining us today from Numerous Networks, and we'll see you again in a future episode. Thank you.
Thank you, Keith. It was a pleasure.